Welcome to Lecture 2.5. I'm going to go ahead and get started, even though there's not anybody in the room. Maybe some of y'all will trickle in. Let me just give you a quick overview of where we're going with this particular lecture. In 2.3, you learned about all the steps to graphing a polynomial function. And the polynomials in 2.3 were able to be factored, and then you could use the zero product property or quadratic formula to solve for the zeros, which are the x-intercepts of the function. And then in 2.4, we gained the knowledge of, well, if this thing can be factored and we're not sure about how to factor it, we can, if we're given one of the zeros, use synthetic division to pull that one out or factor that one out, and then we should be left with something that we know how to factor. So 2.5 takes this idea one step further and says, okay, if you're given this polynomial and you have nothing given to you about it, you don't know how to factor it, how do you move forward with narrowing the field down to figure out what the x-intercepts are? So that's sort of the focus of today's lesson. And so I'm going to walk you through that process, and then the very last slide, we're going to take a polynomial through the entire process. All right, let's get going here. So the first thing that we run across in this section is just a reminder of all the different types of zeros, or all the different types of solutions you can have to a polynomial equation. You've got rational zeros, which can be written as fractions. That's the simplified version of the definition of a rational number. You have irrational zeros, so things that if you put into your calculator, you'd have this decimal string that doesn't repeat or end. You have complex imaginary zeros. We saw these show up in section 2.1 and 2.2 when we were doing the quadratic formula. We were getting those complex. So these can be further broken down into real zeros, which encompass rational and irrational. So just see this division here. And then we have non-real, which would be our complex imaginary zeros. All right, so the bulk of this section is regarding this next theorem here, the rational zero theorem. So once again, let me remind you of the name here, the rational zero theorem. So we're talking about x-intercepts of this form right here. So if f of x is this polynomial, which this is just your long, scary-looking definition of a polynomial, which is really not that scary because we understand what each of those pieces means now. If it has integer coefficients, and so integer coefficients, we're talking about all of the coefficients on the variables. And P over Q, where P over Q is reduced to its lowest terms, is a rational zero of F. Then P is a factor of A sub 0. And Q is a factor of A sub n. So what it's saying is I can figure out all the possible These aren't all going to be zeros, but this is a starting place for you. All the possible rational zeros are equal to the factors, positive and negative, of a sub 0, or the constant term, divided by the factors of a sub n. So that's what P over Q is, are those values that you come up with. Okay, let's move forward and look at an example of this. Okay, so I'm given a polynomial function here, and I'm just told to find all of the rational zeros for that polynomial. And here's the hint. We use synthetic division. And actually, you're going to synthetically divide C, which is that value that comes from the factor x minus C. We're going to synthetically divide C until it fails, because you may have that factor show up more than once within a particular polynomial. Remember, that's multiplicity. We can have a factor show up many times. And that tells how it crosses the x-axis, how the function crosses the x-axis. Okay, let's go ahead and begin looking at this. The first thing we need to do is narrow down our playing field. We need to figure out what are the possibilities for P over Q. So just as a reminder, we have the factors, that's those factors, of A sub 0 over the factors of A sub n. In this case, A sub 0 is 4, and A sub n is -1. So, A sub 0, all the factors of 4. Well, we have positive and -1, positive and -2, and positive and -4. Factors of A sub n, we just have positive and -1, which makes it nice. That means when I do this division here, the only possibilities for the rational zeros for this function are positive -1, positive -2, positive -4. So I have narrowed the playing field from infinitely many possibilities to 6. Now I've got to start the synthetic division process. Remember how to interpret your results from synthetic division and try to factor that polynomial and pull out the zeros. So I'll start that process. We'll start with positive 1. So I want that as my C. Just to remind you, when I am using 1 as C, this is for a factor of x minus 1, x minus C right here. And don't forget, you've got to use placeholders if you skip over terms. So the coefficients that I'll be using for this will be -1 to the 4th. I skipped over x cubed, so I have 0x cubed, 3x squares, 0 x's, and 4. Then I just move through my synthetic division process. Combine down, multiply, write my result. 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 And I get a 6 as a remainder. The only way that your C, or your dividend, your divisor, is going to be part of that linear factor is if your remainder is 0. We talked about that in the last lesson, 2.4. So at this point, I know that positive 1 has failed. It is not a factor because I have a remainder, and that remainder is 6 for that one. It's always the last number that shows up. All right, so I'm going to give negative 1 a try. So negative 1, 0, 3, 0, 4. Combine down, multiply, write your result. 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 Combine down, and I get a remainder. So this is a no-go. Moving on to positive 2. I'll give positive 2 a try. Negative 1, 0, 3, 0, 4. Combine down. Oops. And acting crazy again. Combine down. Multiply. Write your result. 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 That's supposed to be a 4 there. And combine down, 0. All right. So because I have a 0 remainder, let me just clarify what I've done here. With a C of negative 1, this would be a factor of x plus 1, because remember, x minus negative 1. This one would be a factor of x minus 2. So here's what I found out. My polynomial f of x, I now know is equal to x minus 2 times, well, we started out with a 4th degree polynomial. We took it down by a factor of 1, and so this is now a cubic. X squared x and then negative 2. So I have negative x cubed minus 2x squared minus x minus 2. And that's where I start my next synthetic division process. I don't go back and use these first coefficients because I've already pulled a factor out of that. Now I'm trying to figure out how to factor this right here. So those are my new coefficients. And don't forget, you want to try it until it fails, because it may be in there more than one time. So my next process, I'm going to continue with my C of 2. So just to remind you, that means we're talking about another factor. We're checking for another factor of x minus 2. I use my new coefficients, which are negative 1, negative 2, negative 1, negative 2. And see if I can pull another factor of x minus 2 out. All right, so combine down, multiply, combine down, multiply, combine down, multiply, combine down, and you can see that I get a remainder there. So x minus 2 failed on that go around. So I need to try my next possibility, which would be negative 2. So now I'm looking to see if there's a factor of x plus 2 in there. I don't go back to my original coefficients. I use my new ones because I've already factored some. So my C is negative 2, and I have negative 1, negative 2, negative 1, negative 2. Combine down, multiply, combine down, multiply, combine down, multiply, combine down. I get a remainder of 0. So at this point, this is what I have found out. I know that f of x is now equal to my first x minus 2 that I found. Now I have a factor of x plus 2, and my leftover, I started out with a fourth, x to the fourth. I've taken it down by a factor of 2, so this is an x squared plus 0x minus 1. So I have left a negative x squared minus 1. And at that point, it's a quadratic. I could use the quadratic formula with this right here, or I could go ahead and set up the zero product property because I can use my square root property on that one as well because there's no x term. So I think that's what I'm going to do. I'm going to go ahead, instead of continuing with synthetic division, to check for -2, for -2 and for 4 and -4. Since it's down to a quadratic, I'm going to go ahead and finish it off with the zero product property. So I have x minus 2 equals 0, x plus 2 equals 0, and negative x squared minus 1 equals 0. So here, x is 2, and we already figured that out right here. And then we have x is -2 right here. And now we have to solve this one. So negative x squared is equal to 1. Divide both sides by -1, and I get x squared is equal to -1. I have to take the square root of both sides here, and that's going to give me x is equal to positive negative square root of -1. These are imaginary solutions, positive negative I, right there. So those are not considered rational zeros. The instructions were to find all of the rational zeros. So the answer to that, the rational zeros, are 2 and -2. Okay, here's another one to work. Finding same instructions, find the rational zeros. So just another example of taking it through that process. First thing we want to do is identify P over Q. So P are the factors of A sub 0. Q are the factors of A sub n. So A sub 0 is -6. So I have positive -1, positive -2, positive -3, positive -6. A sub n is understood to be 1 right there. So I'll just have positive -1, which means I have 8 possibilities for rational zeros here. Okay, and I'll start my synthetic division process. Pardon me. Let me grab my coffee real quick. A little early, although y'all have seen me drinking coffee at 3 p.m. too. All right. Okay. So let's go ahead and start the synthetic division here. I'll just go in order and give +1 a try first. I haven't skipped over any terms in my polynomial, so I'll just write the coefficients 1, 2, -5, -6, and begin the process. Combine down, multiply, write your result, combine down, multiply, write your result, combine down, multiply, write your result, combine down. Fails because I have a remainder, which means it is not a factor. By the way, this was checking for x minus 1. All right, let's check for x plus 1, which means we will have a c of negative 1. 1, 2, negative 5, negative 6. Combine down, multiply, combine down, multiply, combine down, multiply. Hey, we have a winner. So, first thing I'm going to do before I move forward is interpret my results. That says that my function f of x is, I know now, is equal to x plus 1 times, I started with a cubic, I took it down by a factor of 1, so I'm left with a quadratic, x squared plus x minus 6. Okay, I know how to factor that thing, but I am going to continue with the synthetic division process to factor it instead of using the AC method. I could also use the quadratic formula at this point to solve for x, but I'm going to, like I said, I'm going to continue with the synthetic division process. I need to check negative 1 again because it has not failed yet, just in case it's in there more than once. Negative 1. I use my new coefficients, 1, 1, negative 6. Combine down, multiply, combine down, multiply, combine down, fails. So this is also an x plus 1, a second x plus 1, but it failed. All right, now we're going to check x minus 2. So my c will be 2. 1, 1, negative 6. Combine down, multiply, combine down, multiply, combine down. We have a winner. So interpreting these results, I have f of x is equal to the first x plus 1 that I found. I just found x minus 2, and I'm left over with x plus 3. So I've got it all in linear factors here. And I'll write it up here. And I'm just going to use the zero product property to solve. So x plus 1 equals 0, x minus 2 equals 0, x plus 3 equals 0, x equals negative 1, x equals 2, x equals negative 3. So your rational zeros are negative 1, 2, and negative 3. Moving forward. Okay, we have another rule about the types of zeros that you can expect to see, and that's Descartes' rule of signs. So you start off with your polynomial, and it says the number of positive real zeros is either the same as the number of sign changes or less than the number of sign changes by a positive even integer. If f of x has only one variation in sign, then f has exactly, so one variation in sign, f has exactly one positive real zero. All right. So the number of negative real zeros is the same as the number of sign changes of f of negative x, or less than the number of sign changes of f of negative x by a positive even integer. If f of negative x has only one variation in sign, then there is exactly one negative real zero. Okay, so the first thing we have to do is identify the sign changes of f of x. Then we've got to go plug in negative x and see how many sign changes happen. and then write our conclusion from there. So we're going to fill in this chart. I'll do the positive sign changes in blue here. So we start out, and this is in, you can see this first polynomial here is in standard form. So you're trying to look for sign changes between the terms. So we start out with a positive, and we end up at a negative. There's a sign change. Between the second term and the third term, we go from negative to negative, so same sign. Then the third to the fourth term, we go from negative to positive. There's another sign change. Fourth to fifth, positive to positive. Fifth to sixth, positive to negative. So we have 3 sign changes for f of x. Now f of negative x, first we have to see what's going to happen with f of negative x. So that's 3 times negative x to the 7th minus 2 times negative x to the 5th minus negative x to the 4th plus 7 times negative x squared plus negative x minus 3. So negative x to the 7th is going to be negative x to the 7th, which when I multiply that with 3 leaves me with negative 3x to the 7th. Negative x to the 5th is negative x to the 5th multiplied by negative 2 is positive 2x to the 5th. Negative x to the 4th is positive x to the 4th times a negative is negative x to the 4th. Negative x squared is positive x squared times positive 7, so that's positive 7x squared. Positive 1 times negative x is just negative x, and then minus 3. Now let's go back and count the sign changes. I'll do these in red. So we have a sign change here. 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 So we have 4 sign changes in that particular when we plug in. So we have 4 sign changes for negative x. We have 3 sign changes for f of x. Now let's go back and draw our conclusions. Positive real zeros is our f of x conclusion. And it says it either has the same as the number of sign changes, or it has the number, it's less the number of sign changes by a positive even integer. It has more than one, so it's not exactly one positive real zero. So what this means is our function has either 3 or 1, because that's 3 minus 2, which is that positive even integer. 3 or 1 positive real zeros. Okay? F of negative x tells us about negative real zeros. It either has the same, so it either has 4, or it has less the number of sign changes by a positive even integer. So it has 4, 2, or 0. Frozen. All right. Negative real zeros. So this just tells you what type of zeros to expect before you do the synthetic division process. You can still use P and Q to narrow it down, but you can narrow it down even further by knowing this bit of information about the positive and the negative real zeros. Let me just, there, the red for the negative real zeros. Okay, let's go ahead and analyze these other two polynomials. Let me get my blue pen for the positive real zeros. So no sign change, one sign change, two sign change, so 2. There are 2 sign changes, which means this either has 2 or 0 positive zeros, positive real zeros. Okay, I first need to figure out what f of negative x is, and then analyze the sign changes. 4 times negative x to the 5th plus 2 times negative x to the 4th minus 3 times negative x squared plus negative x plus 5. So this is negative 4x to the 5th plus 2x to the 4th minus 3x squared minus x plus 5. Okay, I'm just going to identify my sign changes. Sign change here, sign change here, and sign change here. So I have 3 sign changes, which means I either have 3 or 1 negative real zeros. Okay, last one. First, going to just locate the sign changes with f of x. I have 1. Okay, so we're told right here if it has exactly 1 variation in sign, it has exactly 1 positive real zero. So this has 1 positive real zero. Wow, E-R-O, sorry. All right, now I just need to figure out what f of negative x is. So that's negative 7 times negative x to the 5th minus 5 times negative x to the 4th plus negative x plus 9. So this is going to be 7x to the 5th minus 5x to the 4th minus x plus 9. So I want to identify my sign changes. We have a sign change here and a sign change here. It had 2, so it has 2 or 0 negative real zeros. All right, that is Descartes' rule of signs. Determine the possible number of positive and negative real zeros and then find the zeros. So we'll determine the positive first, just using f of x. We have no sign changes in this. So let's go back. It has the number of the same number as the sign changes, which means this thing is going to have, there are no sign changes, so there are no positive real zeros. And f of negative x, we need to figure out what that is first. So we have negative x cubed plus 2 times negative x squared plus 5 times negative x plus 4. So this is negative x cubed plus 2x squared minus 5x plus 4. See how many sign changes we have. We have one here, and one here. So that means we're going to have 3 or 1 negative real zeros. Now, what that does for us is it knocks out all of the positive rational zeros that we get when we do P over Q. So we don't have to try any of our positive numbers. Let's go ahead and determine P over Q. So P over Q, these are the factors of A sub 0 over the factors of A sub n. So positive negative 1, positive negative 2, positive negative 4, positive negative 1. So we have positive negative 1, positive negative 2, and positive negative 4. However, we can come back and we don't have to try positive 1, positive 2, or positive 4 because we know we're not going to have any positive real zeros. So you've cut your work in half with this particular one. All right, let's go ahead and begin the synthetic division process using the negative values for C. So we're first going to check for a factor of x plus 1, which means our C value is negative 1. My coefficients are 1, 2, 5, and 4. Bring down, multiply, combine down, multiply, combine down, multiply, combine down. Interpretation. I now know that f of x is equal to x plus 1 times, I started with a cubic, it comes down by a factor of 1, so x squared, x squared plus x plus 4. I need to try it until it fails, so I need to give negative 1 another try. I use my new coefficients because I've already pulled a factor out, so 1, 1, 4. Combine down, multiply, combine down, multiply, combine down, fails. So I'm ready to move on to, this is also a factor of x plus 1, I'm ready to move on to x plus 2. So my C will be negative 2 now. Use my new coefficients, 1, 1, 4. Combine down, multiply, combine down, multiply, combine down, and fails. Sorry, I was looking back up the problem. Okay. The only one I have left to try is negative 4. And actually, I know it's not going to be negative 4, and here's why. I'm told I have 3 or 1 negative real zeros. So unless every single one of them worked, negative 1, negative 2, and negative 4, the only other option is for me to only have 1, and I've already found 1 there. So I don't even have to do negative 4, but I'll do it just to show you that it fails. Bring down, multiply, combine down, multiply, combine down. So it fails. Okay, so it says to find the zeros. It does not specify the rational zeros, so I need to finish this off. Here's where I am so far. X plus 1 times x squared plus x plus 4. All right, so I have one of them right there. I just need to So I can use the quadratic form, the zero product property here. And this gives me -1 is one of my zeros. I'm going to use the quadratic formula to finish this off. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. -1 plus or minus the square root of 1 minus 16 over 2, which is -1 plus or minus the square root of -15 over 2. So that's -1 plus or minus I square root 15 over 2. So you have two complex zeros there. So those are not real zeros. The only real zero that you have, so this thing only crosses the x-axis in one place, and that is -1. All right, one more slide. We're going to take a polynomial through the entire process of graphing. All right, so the end behavior. We focus on the first term, which is x cubed. That means this is a positive odd, which means I have falls left, rises right. Pardon me, x-intercepts and their multiplicity. I have no sign changes with f of x. That means there are 0 positive real roots. If I do f of -x, I'm going to do it in this little space that I have right here. So f of -x is -x cubed plus 2 times -x squared plus 5 times -x plus 4 gives me -x cubed plus 2x squared minus 5x plus 4. So I have sign changes here and here and here, which means I either have 3 or 1 negative real zeros. P over Q to narrow down what those zeros could be. We have P over Q, which is positive -1, positive -2, positive -4 over positive -1. So my only possibilities are positive -1, positive -2, and positive -4. And I don't have to try the positives, because I'm told that there are no positive real zeros. So just the only possibilities for real zeros are -1, -2, -4. Now I start finding them. So -1. And by the way, all 3 of them will be, or only 1 will be, because you have 3 or 1 negative real zeros. So I have 1, 2, 5, 4. 1, -1, 1, -1, 4, -4. So there's a factor. This is checking for x plus 1. So f of x is equal to x plus 1 times x squared plus x plus 4. This is the same quadratic that we had with the last one. Is this the same problem? Anyway, did I put the same one on both? X cubed plus 2x squared plus 5x. It's the same one, so we've already done all the work for this. So we know that these are complex, they're imaginary, they're non-real. And this is our only real, so x plus 1 equals 0, which means x is negative 1. It shows up one time, so it has a multiplicity of 1, which means it completely crosses at negative 1. I'll go ahead and graph that. My y-intercept is what I get when I plug in 0 for x. So that's 0 cubed plus 2 times 0 squared plus 5 times 0 plus 4. So I have 4. Go ahead and mark my y-intercept. And I know that it falls left. And pardon me. Okay, rises right. The last thing is getting the turning points from your calculator. I assume it's going to do a little zippy thing in it because it's a cubic, but I'm not quite sure where that occurs, and that's what I use my calculator for. I mean, if I can put my hands on the graphing calculator. Yes. So I'm going to put the function into the y equals screen. So that's x cubed plus 2x squared plus 5x plus 4. Take a look at the graph. Oh, my battery just died. No. Okay, I'm gonna have to just kind of fudge this one. I assume it does something like that because it's got to have a little squiggle in it since it's a cubic. I may be way off. I don't know what this looks like. I don't have a graphing calculator on my computer, but I know it completely crosses through the x-axis at -1, and I know that the y-intercept is 4. Those are the only real zeros it has, so it does have two imaginary zeros. And that is the last slide I have for you. So don't forget that the quiz over Unit 5 is due not this coming Monday, but the Monday after that. On the 14th. It will open up Thursday the 10th for you. The next lecture over 2.6 will be next Monday, April 7th at 3. So don't forget that next Monday is also when early bird registration for fall opens up. So if you had that early bird advising appointment, then you are cleared to register early for fall semester. Hope that this is helpful for you, and just if you have any questions or anything over the lecture, just send me an email and I'll be happy to help you out. Have a great day.